Welcome back. We can easily scale a distributor system, but what about monolithic system? How can we scale the monolithic system? So, in today's video, we are going to see how we can scale the monolithic system. Let me revise. Monolithic are those systems in which front-end, back-end and database all together are present in a single machine, single code base, and they are deployed simultaneously. So to scale this system, we have two ways. First one is horizontal scaling, okay. Second one is vertical scaling, okay. So let us see each of them. Suppose you have a system of front monolithic where front end, back end and database all are present, and you have a different application requests are coming, okay, in your system. You can easily handle. But if your system get very popular, or if your software get very popular, lots of people coming here, and the system capacity of, suppose the system capacity is 1 TB and 16 GB is not enough to handle all the people. So what will you do? The first thing you will do is you go and buy one more configuration and scale it to 2 dB. Instead of 1 dB, you scale it to 2 dB. Or if more people come, you scale it to 3 dB. Okay. This type of scaling means adding one more layer of same system is called vertical scaling. Okay. But this type of scaling has its own limitation, and there are two very important limitations. First one is, after a certain point you can't scale this system. What is it mean? Okay, if this is a scaling and this is performance, okay, so for certain scaling it is very good. Adding one to other block is very good to certain limit, but after a limit you can't use this. That's the reason many big company never use, if this company follow monolithic system, never use vertical scaling, because after a certain point you can't scale this system to a very high. And second most big problem is, all the system are present in one machine. Here you just extra add the configuration, just like you add, some people add extra configuration to their laptop, increase their memory value or increase their RAM, just like you are doing here. So the machine is only single one. So here the chances of single point of failure means if any failure happen here, your whole system get collapsed. So single point of failure is a very big issue in this type of scaling. There are two important issues. First one is single point of failure. Second one is, after a certain point you cannot scale your system. Just like think about your laptop. In your laptop you can add a one extra GB of RAM, or you can add one extra TB of hard disk. But can you add infinite? No, you cannot do that. That's the level. And if anything happen to your laptop, your all the data get collapse. That's the thing happen here. That's the two main limitation of this type of scaling. First one is you cannot do a infinite number of scaling. Second one is single point of failure. So to solve this issue, we have another scaling that is called horizontal scaling. In horizontal scaling, suppose there is a one machine, okay. So you horizontally divide this machine into different parts. Suppose it is a 1 terabyte of machine, okay. So now you have 4 machines, they are connected over network call, and each one has a 1 TB of data, okay, 1 TB of data, okay. Now this type of scaling is called horizontal scaling, where you distribute the load. Let's again explain it by the laptop example. Suppose you have a one laptop, now you have a issue problem. So you buy second laptop, third laptop, fourth laptop. Here you can buy infinite laptop and there will be no problem. It is called distributed monolithic scaling. So now you get confused. What is the now difference between horizontal scaling and distributed system? Because in distributed system we also use the same technique. We also buy lots of system to connect, but there is a very big issue here, very big difference. What? In horizontal scaling, when we divide the system into different parts, every system has all the three things: front end, back end and database. Front end, back end and database. So if any client comes, it can complete all its work from the one system. There is no need of another system. Suppose a machine can handle 10 clients. You get 20 clients. So 10 client goes to first machine, 10 client goes to second machine. But in distributed system, this is not happen. In distributed system, maybe front end present here, back end present here and database present here. So suppose a client come here, it happened front end get his business logic from back end get his data from database. So for this single client you need network call, but for doing a single work you do not need network call here. Network call here need for another work. I explain in the upcoming video, in same video, okay. But due to this type of scaling in monolithic, there is a one limitation. What is that limitation? Selective scaling. You can't do selective scaling. Just like in distributor system, if you wanted to increase your database, you can increase your database machine size. But here you cannot do this, because if you wanted to increase the database, you have to increase everything: front end, back end and database. I hope you understand it. So selective scaling is not possible in horizontal scaling. Selective scaling is not present in horizontal scaling. And second problem is, I said you that in horizontal system everyone is connected over network call. Why it is connected over network call? Suppose if any person come and change any data, okay, any data, and that data change from D to D2. Suppose second person come and check the data here, what will happen? You need to change data also in every machine, otherwise the consistency is not present. So for consistency, if any machine get any type of changes, so to change it in every machine you need network, okay, you need network. So here consistency is very big issue, because if you change anything in single machine, you have to change in every machine. That's the big issue. But in distributor, why it is not so big issue? Because there are lots of systems. So I said you replication. One data is present in 2 or 3 machines. Not every machine contain the same data. So if any changes happen in one machine, you have to change only 2 or 3 machines. But here if you have hundreds of machines, every machine have the same type of data. So you have to change in hundreds of machines. So I hope you understand here. Here consistency, maintaining consistency is big issue than maintaining consistency in distributed system. I hope you understand from this point of view that scalability in monolithic happen with the help of two different techniques, horizontal and vertical. In vertical, we can just increase the capacity of machine by adding more and more configuration, but here single point of failure and is very big issue. And other issue is that after a certain point scaling is very expensive. Second, we go for the horizontal scaling. We divide the load into different machines. Here it is different from distribution machine. And again we discuss about the horizontal machine cannot do selective scaling. Then we discuss about consistency is very big issue in the horizontal machine. That is not present in the, it is present in the distribution machine, but it is not that hard. Just hard is present in the horizontal scaling. I hope you understand all the concept. We will meet in the next video. Till then, goodbye.